Remember, if you need to ask me anything, first go to raise your hand, IM me, Kmail me, or call me. 4 different ways there. Okay, this is Solid Shapes in 3D Drawings, Part 2. So let's get going here. What we're going to be learning in this is to identify orthographic views, to compute the surface area, to compute the volume, and identify the solid generated when a plane figure is revolved about an axis. That sounds pretty hard. I don't think it is, though. New terms that we're going to be discussing today are the orthographic views, surface area, and volume of a solid. A lot of them probably aren't that new to you. Okay, orthographic views. It's a view of a three-dimensional figure that show the front, back, top, bottom, left side, and right side views of the figure. So here we've got this triangular pyramid. It's a one-point perspective. Down here is your set of orthographic views of this triangular pyramid. Notice the left, right, front, and back all look the same. Top and bottom look the same too, except here you're seeing where the triangles come together at the vertex. I bet y'all are very used to orthographic drawings. Most people do really well with them. This is what you're used to. Well, this is an isometric right here at the top. This is what you're used to seeing on your standardized test. They'll give you this drawing right here and tell you to pick out which ones are right and not right and things like that. Okay, so the surface area of a figure is the amount of space that covers the figure. To find the surface area of a solid, find the sum of the areas of its outer surfaces. This is the long way, okay? But sometimes it's easier to learn the long way and then use the formulas for a shortcut, because the long way can always save you when you forget the formula. So the first thing we're going to do is find the area of the top. There you go. Now if you look here, if I'm looking at the top, I know that this area of the top is length times width, right? So I know this length is 12, I know this width is 5, 12 times 5 is 60, so I know that top is 60 inches squared. Then I'm going to do the front. Then again, you got length times width, so you've got 12 inches times 3. That gives you 36 inches squared. Okay, and since it doesn't tell us that that's exactly what we're looking at, but when you're looking at a right rectangular prism, your top and bottom are going to be the same, and the front and back are going to be the same, and your left and right are going to be the same. So you really don't have to do 6 calculations, you just got to do 3. But we're going to do all 6. Okay, the third is the area of the left side. Here's the left side. Whoops, right there's the left side. And if you look, you know that your length here is 5 and your width right here is 3. There you go. 5 times 3 is 15 inches squared. You go through, you do the same thing for the right side. There again, you got your length and width is 5 and 3. So there's another 15 inches squared. Then you're going to do your back. It's length times width. You know you've got, what, 12 times 3? Remember I told you your back is going to be the same as your front? I wasn't telling you a story. 12 multiplied by 3 is 36 inches squared, which is the same as the front. And then the bottom is also length times width, and that looks like it's going to be 12 times 5, which is 60. And I remember I told you your top and bottom will always be the same. Then you just add all those guys together and you got your total surface area of 222 inches squared. So now let's look at volume. The volume of a solid is the amount of space inside the figure, measured in cubic units. Here's the equation that y'all are so used to seeing for volume: length times width times height. So let's see what we're doing here. Oh, look at my length is usually represented by, it's usually a cursive L. And here's my length. I showed it on the picture. with these orange shading. Okay. Then we got our width is represented by a little W, and there you go. I shaded it over here so you could see the width. It's 3 units. And then your height is represented by lowercase h, and it's 4 centimeters. And you can see I'm counting it right here. So if I go back, volume is length times width times height. I plug in those numbers, multiply them, and I got 60 centimeters cubed. So let's go through some examples right quick. It says this isometric figure is composed of cubes that have a length of 2 centimeters on a side. Okay. How many faces does this three-dimensional figure have? Well, you're going to have to go through and count your faces. Okay. This right here, that all represents one face. Well, this is the front, and you know the back is there. You just can't see it. So that's 2 faces. Now this is where it gets tricky. You got the bottom face that we can't see. So that's 3. There's 1, 2, 3. Here's the right side. That's 4. And here's the top. And here's the top. Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8. Here's the left and here's the left. I can't remember if they counted those as 1 or 2. 8. See, there you go. I told you 8. I was right. Just couldn't remember. 4 are visible and 4 are hidden. So here's our 4 that are visible. Okay, there's 1, 2, 3, 4. The 4 that you can't see is this left side here, this left side, the back, and the bottom. Describe surface area in terms of the figure. I kind of just spit the answer right out there instead of talking to you about it. The surface area is the sum of the areas of the 8 faces of the figure. Okay, so you'd have to take the surface area of the front, surface area of the back, surface area of the right, and so on, and then add all those together. And that's what we did here. Now remember, I put inches in my problem and it's centimeters. Y'all have to forgive me for that. It says that the isometric figure is composed of cubes that have a length of 2 centimeters on a side. Okay, so each cube represents 2 centimeters. Okay, and my front, if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go through like that. I'm looking to see. Oh, I see how I did it. 1, 2, 3, 4, 5, 6, 7, 8. There you go. 2 times 8 represents this length right here. Okay, and then 3 by 4 represents, okay, here's the 2 by 8. Alright, here's the 3 by 4. Okay, 1, 2, 3, 1, 2, 3, 4. Okay, 2 by 8 is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There you go. Hope I haven't confused you too much because I kind of confused myself. Anyway, so 2 times 8, 16, 3 times 4 is 12. Add those together, I'm going to get 28 inches squared. The back is going to be exactly like the front in this picture. Now the 2 top faces, I'm going to have 5 by 2, which we went here 1, 2, and then 1, 2, 3, 4, 5. And then up here you've got 3 by 2. Okay, add those up or multiply them and then add 16. Your bottom's going to sort of be the same. We can't see it, but we can tell what the cubes are. We know that it's 2 cubes for your width, 8 cubes for your length, and then you got your length times width is 16. Your right side is going to be 2 by 6, so you've got 2 and then 6 down. 2 times 6 is 12. You got your two left faces. Add all those up together, you got 112 centimeters squared. Okay, we answered what is the surface area. Okay, D says describe the volume in terms of the figure. Now when it says describe, that means give me a verbal description. Don't do the math. Tell me verbally. Well, in this picture, the volume, well, in all pictures, the volume is the total number of cubes that make up the figure. Sometimes you don't have cubes, but we'll talk about that when we get to it. What is the volume of the figure? And here, this is kind of crazy. You're thinking, oh no, where'd all these numbers come from? Why aren't you just doing one length times width? Well, our picture here is in different sections. So what I did was, for one of my lengths, width and height, I went by this, trying to make sure this is the one I went by. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 2, and 2. Okay, that's exactly what I did. Because I have 1, 2, 3, 4, 5. That represents this 5 right here. I've got 2 tall and then 2 wide. That represents that 2 and 2. Over here, I've got 3 inches, 3 centimeters. 1, 2, 3. Okay, and then I've got 2 inches deep. 1, 2, and then 6 inches. 2, 3, 4, 5, 6. That's the height. Anyway, when I multiply those two groups in parentheses and add them together, I'm going to get 56 inches cubed. Okay, what we've done today is we've talked about the orthographic views, or two-dimensional views of three-dimensional figures. For simple solids, there's 6 orthographic views: front, back, top, bottom, left, and right. And all 6 views are needed to understand what the figure looks like. And we learned how to find the surface area of a three-dimensional figure by adding the area of the faces. And we also learned that you can find the volume of a rectangular solid by multiplying length by width by depth, or we're used to calling it height.